Okay, hi everyone. So for today's lesson, we are going to learn chapter 1, physical measurements and units. So we will focus on dimension of physical quantities. So before this, we have covered this learning outcome, which is determine the dimensions of derived quantities. So a bit revision, we know that the dimension for length is L, dimension for mass is m, dimension for time is t. So these three basic quantities is very important to determine the dimension of derived quantities. Okay, so for today's lesson, we are further down to this learning outcome. So we will be verifying the homogeneity of equations by using dimensional analysis. So I believe you have come through this statement because this is from your lecture. So refer to your lecture note page 6. You have learned that the dimensional analysis can be used to determine the units of the physical quantity to determine whether the physical equation is dimensionally correct or not. So if you have an equation, the dimension on the left hand side is equals to dimension of right hand side. Therefore, we can state that this equation is dimensionally correct. Okay, so how to use this statement in verifying homogeneity of the equation? So let's look at example 1. So determine whether the following expressions are dimensionally correct or not. Remember, if they are correct, the dimension left and right is the same. So we have left hand side f, frequency, and we have right hand side 1 over 2 pi square root g over L. Okay, so let's look at their dimension. The dimension for frequency. We know that frequency have units per second. So the dimension for frequency is t negative 1. For right hand side, if you have the constants like this, you can ignore in your calculation to check with the dimensions of the equation. So let's take square root g over L. So the dimension square root g over L, we have a g is a unit for g, gravitational acceleration, is ms negative 2, length is meter m, therefore the dimension is lt negative 2 over L. Cancel this out, so we have square root t negative 2. So we know that square root is power of half. So we will get the dimension of g over L, square root g over L is t negative 1. So we can see that left hand side of the equation, the dimension is t negative 1. Right hand side of the equation, the dimension is t negative 1. So we can say that the dimension of left hand side of the equation is equals to dimension of right hand side of the equation. Therefore, the equation is dimensionally correct because they have the same dimension. Okay, so you may try the questions number 1 and 2. I put the answer over there. If you can't answer it, try to look at again this example, or you may come and DM me or DM in the group if you have any problem.